In the world of high-temperature superconductors, Theva is the leading manufacturer of thin film coatings with unparalleled performance and reliability. This short video clip will convey an impression of the commercial fabrication of such YBCO films. The production of HTS films is based on thermal vacuum evaporation. At Theva, this technique has been developed to perfection. It allows single and double-sided deposition on practically all standard substrate materials, such as magnesium oxide, sapphire, or lanthanum aluminate. The oxide superconductor is formed by evaporating the metallic ingredients, in this case yttrium, barium and copper, simultaneously from resistively heated tungsten and tantalum boats. From the boat sources, the metal vapors spread in vacuum until they reach the substrate wafers. To supply the necessary oxygen, the wafers are mounted in a rotating turntable and passed through a pocket with enhanced oxygen pressure. The passage transforms the metals into the high-temperature superconductor oxide-growing single crystalline on the substrate surface. The proprietary turntable substrate holder comprises heater elements behind and around the wafer reception to establish a uniform deposition temperature of around 680 degrees centigrade. The narrow clearance between the oxygen pocket and the wafer holder plate acts as a slit seal with high flow resistance, so that the oxygen pressure in the pocket is nearly 3 orders of magnitude higher than in the surrounding vacuum chamber. In order to adjust the chemical composition of the films accurately, the metal evaporation rates are monitored and controlled individually by oscillating quartzes. This offers enormous flexibility for optimizing the composition and film properties for specific applications. Prior to deposition, each substrate is carefully inspected and cleaned by spinning with alcohol. To avoid contamination, the wafers are mounted in the substrate holder plate under laminar airflow and transferred to the deposition chamber in a sealed box. In a final step, the boat sources are filled with the granular evaporation material. The system is pumped down, and after reaching the deposition temperature, the coating process starts. The operation of the system is computer monitored, and all process parameters are recorded for a detailed documentation of each individual deposition run. After cooling down in oxygen, the films can be removed from the chamber or flipped over for double-sided deposition. Additional boat sources allow in situ coating with contact, buffer or cap layers. The film deposition is followed by an immediate and close quality control. The scanning electron microscope serves to check the structure of the film surface, which is characteristic for the composition. Films can be fabricated custom designed for various applications, from extremely smooth for multi-layers to rugged with a high density of pinning centers for microwave applications. Another standard inspection is the mapping of the uniformity of the critical current density by a cryoscan. Measurements of the transition temperature and the microwave surface resistance are performed as spot checks. As a final result, superconductor wafers exhibiting well-documented and certified properties are ready for shipment to our customers all over the world.